you for coming, everyone. We really appreciate this. We know it's the end of the day. We're all that sits between you all and dinners and happy hours. So really, really appreciate you coming out and joining our talk today about data quality. So why are we here, right? Why are we all here? Why did you all stick around in order to see this presentation? Well, we are here because enterprise data quality is broken. Show of hands, not too many in the audience. I'd love to see show of hands. Who here has experienced a data quality issue at their business? Go on, put them up. Don't be shy, don't be shy. You're not alone, right? What we're seeing is that 91% of people think their companies need data quality improvement. 91%, right? So maybe there's one of you that didn't raise your hand that falls to that 9%, but those of you that did raise your hand, you're absolutely not alone. Even more concerning is that 82% of IT decision makers have reworked data projects due to poor data quality. This is huge, right? You are here at the Data and AI Summit trying to figure out how to bring data to your company, how to deliver data-driven products and make data-driven decisions. But far too often, those undertakings and those endeavors are hurt by data quality. So that's why we're here, but who are we? I'm Amy Reams, this is Taly Kanfi, and we're with Anomalo. So at Anomalo, we are rethinking data quality. Now, rethinking is a really important word here because data quality is not a new concept, right? You all raised your hands. If I would have asked you the same question 10 years ago, probably would have raised your hand then too, right? I'm seeing people nodding their heads, shaking their heads here because we have experienced data quality for quite some time in the data journey here, but it's all about rethinking it. Right? We want to go away with this approach of hiring dozens and hundreds of data engineers to create and maintain data quality rules. Right? We want to break that mold and think about data quality differently, which is what we're doing at Anomalo. But we're not rethinking data quality alone, right? We're rethinking data quality with Databricks. So for those of you that didn't know, we actually were named the Emerging Partner of the Year. And this is solely because of, this is solely because of that innovation as far as how we're helping businesses like all of you bring trust in your data, bring trust in the data that you use to make decisions, to build data-driven products. So again, I want you to think about this concept of rethinking data quality. What are we going to talk about today? We're going to cover 4 key areas. First, how high-quality data and why high-quality data is the new gold. Right, we'll talk a lot about that, and then introduce what we're doing at Anomalo with Databricks. Taly here is going to go into details on how we do it and why we do it. Right? There's a lot of buzzwords being thrown out: data observability, data quality, AI powered. Right? What do we mean? Taly's going to show you what we mean. She's going to show you your different approaches, different ways of doing this, then go into the weeds of how Anomalo approaches this. Again, how we're rethinking data quality. Last but not least, very, very excited for those of you I know that are reading Anomalo's press releases as often as I am. Just today, we announced a new product, a brand new product for unstructured data monitoring. So this is really exciting. We're really, really thrilled to show you a sneak peek of this product today. We're doing a private beta now. Happy to tell you more and help you learn more at our booth as well. So stick with us. This is going to be a good 30 minutes or so, and then we'll take some questions at the end. All right, so high quality data is the new gold. All right, those of you that are data nerds like myself probably saw the recent Salesforce ad starring everyone's favorite rom-com actor, Matthew McConaughey. Not sure what he has to do with data, but nonetheless, Matthew McConaughey went on to say in this ad that if AI is the next frontier, then data must be the new gold. But what our friend Matthew got wrong is that it's not that data is the new gold, it's that high quality data is the new gold. Right? If you're going to endeavor on this next frontier, again, you have to have absolute trust in the data that you're using to power your business. But what is that gold mining challenge, right? If you agree, and I see a lot of people agreeing in the audience that you want to use data on this next frontier, why is it so hard, right? Why is it so hard? It's because you need to build the stack to leverage data within your enterprise. This is a very, very abbreviated version of what your stack probably looks like, right? You have different data sources at the bottom, from SaaS applications, data feeds, events, feeding into your data warehouses and data lakes like Databricks. You might be using data transformation and orchestration tools like a dbt or an Airflow. But ultimately, you're doing this for the top 2 reasons, right? I encourage you to take a look at the top of this screen because you're using data in order to make better data-driven decisions, right? This is BI analytics, or maybe regulatory reporting for financial services customers in the audience. But you're also using it to build data products, right? This is ML and data science. But the reality is that for a while now, as you build out this stack and try to take advantage of more and more data within your enterprise, you're running into a myriad of issues. And I see that my subtitles are covering these up, but I'm sure those of you that raised your hands can talk about what these data issues are, right? They're duplicate data, missing feeds, JSON changes, late data. At the transformation level, you might have SQL bugs or job failures. So what does that mean? You just all bought this shiny new toy that is Databricks, but unfortunately, by the time that data gets to Databricks, it's delayed, it's incomplete, it's invalid, or it's simply anomalous. And so this has major downstream impacts when you think about how you're trying to use data within your business. Right now, you're making decisions off of misleading metrics or broken dashboards. Or even worse, your customer experience that you tried to personalize with data science, that's impacted as well too, because you now have incorrect data feeding the models that is different than what the models were trained upon, right? So this is what data quality has to do with your enterprise, right? This is what we talk about with data quality being broken, because as you invest more and more in building a modern data stack, you also are now plagued with more and more data quality issues. Unfortunately, this is just gonna get worse, right? I'm sure all the people that raised their hand talking about data quality issues also are now thinking about generative AI, right? How do we leverage generative AI within our business? The reality is data is the core to anything you are going to do with generative AI, right? But the problem with that is that there's gonna be no off-the-shelf model, right? You can't just say, here's an off-the-shelf model, go run generative AI for me at my business. No, you need to bring your data to the models, right? Both structured data as well as unstructured data. But when we think about unstructured data, it's not just those yellow boxes that I just showed on the last slide. Now we're talking about formatting issues. We're talking about monitoring for sensitive information and abusive language. We're talking about inconsistencies within the data or duplicates within the data. And we're talking about sentiment analysis, right? This is just extrapolating the issues that we talked about before when it comes to how you use data within your business. Good news is I'm here to tell you that Anomalo is here to help, right? Anomalo and Databricks, again, we are rethinking data quality. We are helping you on this next frontier. We are helping you use high quality data within your business. And Taly's gonna talk more about that, but I do wanna emphasize briefly how we do this with Databricks. As I mentioned before, Anomalo was named the Emerging Partner of the Year. And the reason that we are named the Emerging Partner of the Year is because the extensive ways that we are thinking about data quality, right? We are the only data quality partner of Databricks that's combining both data observability and data quality monitoring. Now's the time to get out your phones, right? If you're gonna send to your company, what did I learn at the Data and AI Summit? You can tell them you learned the difference between data observability and data quality monitoring. Data observability, this is about catching data movement failures, right? Think a lot of your data engineering use cases trying to understand, did my data arrive on time? Was there the amount of data I expected there to be? Extremely, extremely important. But what data quality monitoring is doing is looking at drift within the contents of the data themselves, right? Really helping you understand if the data that you're storing in Databricks is of high quality. And this is really our sweet spot, right? We certainly do data observability, but where we really excel is working with enterprises to also do data quality monitoring and monitor drift within the contents of the data asset. Now within data quality monitoring, what we do is we take an AI-first approach. So Taly, as I mentioned, is gonna show you a lot more about how we do this in just a second. But I want you all to understand, again, with this concept of rethinking data quality, is that we're going beyond just a rules-based approach and a deterministic approach to data quality with validation rules or key metric checks. And we're using machine learning to automatically detect issues within your data. This is huge, right? Because again, you do not need to hire the swath of data engineers. You do not need to create or maintain validation rules at scale. You can just simply point Anomalo to your data that you're storing within Databricks. We will monitor that data. We will profile that data, tell you what good looks like, and then tell you if it's ever outside of the bounds of good. And again, I'm sure you're thinking, how do you do it? I've heard these words before. I promise you, Taly will walk you through exactly how we do this and why it's so novel in just a second. Good news for all of you, we are natively integrated with Databricks, so you can monitor any Databricks table across the entire data and AI lifecycle. This includes Delta Live tables, Delta Lake, and of course, we're fully functioned Databricks SQL, which I know you've probably all heard quite a bit about this week. We also have a native bidirectional integration with Unity Catalog. Right? Governance is obviously a super important piece when we think about this concept of high quality data being the new gold. But a key piece of governance is also having trust in that data asset. And I'll show you what that looks like in our integration in just a second. Last but not least, we offer an exclusive free trial via Partner Connect. So for those of you that are not going to go to the happy hours after this, go home, go to Partner Connect, check it out. You can play around with our UI right away. Here you see a quick image of our integration with Unity Catalog. For those of you familiar, that's actually the Data Explorer UI within Unity Catalog, where you just saw Anomalo's check results featured directly within the UI. So your data stewards can view within Unity Catalog if you have any issues within the data asset itself. Click into the Anomalo UI, find out what went wrong and where it went wrong within your data, and get a root cause analysis of those data quality issues as well. What does that mean for you? Right? It means you as a company are going to be able to take advantage of two key things with Anomalo and Databricks. First, you're going to be able to promote data trust. So this is a story from one of our customers, Block, who I love the last line of this, is that since deploying Anomalo, they spent less time firefighting issues and more time using data to build products our customers love. Right? We've all seen the billboards around San Francisco this week saying, you are a data and AI company. And it's true, you are, but at the end of the day, you're also delivering products to your customers. Right? That's why we're all here, to deliver products our customers love. You need data to do it. This is another one of our leading Databricks customers who's one of the top 3 fast food restaurants in the US. And what they did is they deployed Anomalo across dozens of teams, right? So supply chain, analytics, HR, finance teams. And what they were able to do is actually drastically decrease the amount of time spent in employee hours that would have been spent on building and maintaining rules, right? Again, think about this rethinking data quality concept. They actually saved over 100,000 FTE hours, which would have cost them over $6 million in less than a year. Right, so time saved and more innovative products on this next frontier of data quality. So now I'm going to hand it off to Taly, who's going to talk much more about how we do this, and then I'll wrap it up by telling you more about our unstructured data monitoring product.
Okay, so let's take a deeper dive into our algorithm. Before coming up with a new algorithm for how to do easy data quality, we need to define our success criteria. So here we have 5 attributes that we're going to measure different algorithms that you can use for data quality against. So the first thing is ease, right? How easy is it for you as a data person in your organization to configure a data quality check on a table? The second is interpretability, right? Do you understand when there's a problem, what that problem is, and what, not just the data lineage of the problem, but its business meaning? The third is scalability. Can this algorithm scale to tables with billions of rows, with hundreds of columns, and then across the thousands of tables in your enterprise data warehouse? Finally, how sensitive is an algorithm? Can it find a problem with a single row of data? And how comprehensive is the algorithm? Can it cover all of the issues that happen across all of the rows and columns of a table? So now we're going to talk about some of the existing methods that I'm sure many people in this room are familiar with. The first is validation rules. This is kind of like the tried and true. If you've been doing data quality in some way, you've been doing validation rules. The simplest example I can think of is a database constraint, like a primary key or not null database constraint, but it can be any arbitrary SQL that you set up that lets you know if your data quality is good. And the problem with these is that it takes a lot of man hours to set up all of these rules. The example I always come back to is, how many hours of my life have I spent figuring out how many nulls are okay to have in a column? The answer is many, many hours of my life, right? Almost the easy case is a column that has never had any nulls, and then you can just say like it should never be null. But the harder case is a column that has some nulls, but an anomalous increase in nulls would be a problem that your business wants to take care of. So is it 10%? Is that the correct threshold? And then the data changes over time. Is 15% now the correct threshold? So that is man hours that your data engineers, that your data analysts are spending figuring out what normal is. And that's because these validation rules require you to express as the analyst your prior beliefs on the data. So scaling up from this, we have metric anomalies. You're probably using this already on your key KPIs of your business. If sales are anomalous, then maybe you're getting an alert to say it was an abnormally high, which is hopefully a good thing, or abnormally low. And you can also use this to detect data quality issues. But to go back to my not null example, you're probably not using the machine learning engineers in your organization to figure out how many nulls should be in one of the columns, one of the hundreds of columns in one of the thousands of tables to your warehouse. And even if you did, you would still have this problem of false positives, because when you have thousands of tables with dozens or hundreds of columns each, even at a 99% confidence interval, you're going to get many, many alerts each day. So the question that kind of drove the founding of Anomalo is, could there be a better way? Is there potentially a third algorithm that has advantages over these two existing methods? But first, let's compare these two existing methods on the success criteria that we defined before. So are they easy? They're not easy because you need to specify the specific SQL for the rule, the conditions that you need to be met, the metric that you want to monitor explicitly in code. Are they interpretable? The same thing that makes them hard to do actually makes them really interpretable. Because you defined what you expect to happen, you can understand what happens when it goes wrong. Are they scalable? Neither of these methods is really scalable because you typically are doing things at a column level, even if there's some other columns that are filtering together. So when you have an enterprise data warehouse that has thousands of tables with dozens of columns, it gets big really fast. Are they sensitive? This is where these methods shine, especially validation rules. If you need to find a single malformed zip code in your data, the best way to do it is still with a regex. And finally, are they comprehensive? Do they cover the entire table? And they don't, because you need to specify the conditions in the table that you want to monitor. So what we're looking for is something comprehensive that you can point the algorithm at the table level rather than kind of at the column level. So what's behind door number 3? AI-powered monitoring, which we also call our unsupervised machine learning algorithm. And the idea here is that it's exhaustive validation with no setup. You just point Anomalo at a table, and it'll give you this broad level of coverage against common issues and unknown unknowns. The con is that it's not as targeted as other methods. It's still not going to find that single malformed zip code. So this is what we're going to talk about today. It sounds too good to be true, but it's not. It's just a lot of really insightful work. So let's talk about how it works. So this is some example data that we use in a lot of our demos. It contains a bunch of fake ticket sales. You can see the events, and there's musicals and concerts. Has anyone here heard of The Who? It's a concert in Texas. Is anyone else offended that it's classified as pop in this data set? So that's actually not a data quality issue. That's an incorrect opinion expressed in the data. As you can see, when we visualize the entire data set, all of the concerts are categorized as pop. But this is something that's very cool in our product, is that it's a visualization-rich tool. So we're going to give you a lot of context on your data, and this will show you kind of the top values for the columns in the table. So you can see that we have concerts and shows, and that the categories are pop, plays, and musicals. And this is what Anomalo looks like on the table. And we're focusing on one of our algorithms, which drives the missing data and table anomalies check. But as Amy discussed, there are other things that we do, including the data observability. We do data freshness and data volume, which lets you know if your data is late. And we do have key metrics and validation rules, because even though they have their pros and cons, we find that our unsupervised machine learning algorithm will cover 80 to 90% of your use cases, and then we have a full library of low and no code checks for that 10, 20% of your use cases that aren't covered out of the box. So who here has heard of the Netflix chaos monkey? It's this very cool concept where they randomly terminate virtual machine instances to make sure that their engineers are building resilient infrastructure. At Anomalo, we have the chaos llama, which randomly introduces data quality issues to make sure that our algorithm is robust and can find all of those unknown unknowns in your data. So what does this look like in practice? We have this whole library of chaos operations, which is what we actually use to test the algorithm to make sure that it's able to find all different types of data quality issues, right? So it can look for dropped values in a column, multiplicative growth in a column, a shuffling of the values in a column, and this is how we test our algorithm. But just to show you what it looks like if one of these things happen, I'm gonna go into the database and manually introduce some chaos. I've seen a lot of data quality issues over the course of my career, and someone going rogue and updating the rows is actually one that I've never seen live, but let's imagine I'm gonna go into my table, fact listing, and I'm gonna take the price per ticket column. And that's how expensive the tickets are, but why not have cheaper concert tickets? So I'm gonna take the value 10, I'm going to assign it to 30% of the rows, and I'm gonna constrain this problem just to New York, so it's not affecting the whole table and I won't get caught with my diabolical plans. And I'm only going to do this on a single day's worth of data. So this is our same table. It looked healthy in Anomalo, but I'm gonna rerun the check after this egregious manual intervention, and let's see what happens. So we see that the check is starting to run. We're running a SQL query to pull a sample, and then it's gonna keep running and then build the machine learning model and then generate some visualizations. And when it finished, I can see that the check has failed. That's what that yellow exclamation point means. And the important thing is that it fails without knowing anything about the change. I didn't have a specific rule set up on that price per ticket column. It's checking the whole table. I could have picked any column to randomly introduce shenanigans into. And then we have all of this additional diagnostic information that you get about the anomaly. So we have this price per ticket that the value 10 has increased. It detected that on its own, and it's telling us that this is a severe anomaly that exceeds the learned threshold of noise in this table. So we'll talk more about the learned threshold later and how we make sure that we can handle different types of tables that have different amounts of noise in them. We also show you a lot of visualization. So we have this distribution of ticket prices, which you can see is a high cardinality column with a variety of different values, but you see this spike in values of $10 tickets, and it's only 10% of the overall data set. We also show you a sample of good and bad records, and this is one of my favorite parts of the product because I've worked in analytics for 18 years, and whenever you find a data quality issue, you have to work cross-functionally to fix it. And the first question you get is, can you send me a sample of the rows where the issue is occurring? So we show you a sample of the rows that have the issue and also a sample of the rows where the issue is not occurring. And typically, if you've been resolving these things, that's where most tools stop, where you have the bad rows and the good rows. And this blue dot in our product lets you drag through and see a sample of 100 rows, and then it would be on you, the analyst, to be one of these things is not like the others. What do all of the bad rows have in common that the good rows don't have? But we do that automatically for you, and we call it our root cause analysis. So we're looking for the column value pairs that the bad rows over-index on. And you can see here that we've correctly identified that the chaos I was causing in the database was constrained to venue state New York, which is also correlated with New York City. Now, 100% of the bad rows are in that segment, but only 30% of the good rows are in that segment. So how do we do this? And the way we do it is by taking random samples from today and yesterday, and we're asking the question, is there any material change between the dates? But what we need to do is turn this business question into a machine learning question. And the way we do that is by reframing it as, can we predict which day each record came from? And we're gonna auto-encode the results and the features in the model. So we're gonna make 1 for today and 0 for yesterday, and then we're able to use machine learning methods to predict which day the data came from. Because we wanted this to be industry agnostic and to work for tables of all sizes, we're gonna automatically encode the features, such as day of week, day of month, and day of year seasonality. We're also going to take holidays into account in our auto-encoded features. And then we're able to build a supervised machine learning model where we're predicting the day that the data came from using a gradient boosted decision tree. And what you can see here is the log loss chart that shows the error reducing, and that means that the model is learning. So if I pulled up this same chart on a day where I hadn't introduced an anomaly, I would see kind of a straight line across the top, which would mean that the model isn't learning. If you can predict the difference between today's data and yesterday's data, that means that there is an anomaly that you need to investigate. But it's not enough just to tell you like, hey, there's an anomaly in the data. Then you're off on a wild goose chase as a data engineer or a data analyst trying to find it. We need to be able to tell you what that model is. If you remember what that anomaly is, if you remember our success criteria, right, we talked about these models being interpretable. So the way we do that is using SHAP values in order to credit changes to table values. And what I mean by table values is the individual row column value in the table. So here you have that same data set that I showed earlier, but we have the SHAP values overlaid as a heat map. And we call in the product these SHAP values the anomaly score. You can see in this example that the price per ticket column is a much darker red than the other columns because that's the column where we introduced the chaos. So you can see that the SHAP algorithm is a pretty effective way for identifying how much each column value pair in the data contributes to the overall model. And that's what lets us do these visualizations, which explain the anomaly that we found in natural language, right? So we're able to say, hey, the price per ticket value of 10 increased, and we're able to identify correctly that it was confined to the state of New York. And we're able to show you that histogram where you can see it popping out from the prior day's data. So what are some challenges to this algorithm, right? It's easier said than done. There were a lot of things that are happening behind the scenes that I wasn't able to talk in detail about today. So the first is seasonality, right? Which is say the same change happens every week. In order to do that in the product, we actually compare not just today's data to yesterday, but also today's data to the same day last week, to the same day 2 weeks ago to control for those types of changes. I'm sure there's some machine learning experts in the room that already know what column would always perfectly predict which data came from today and yesterday. And the answer is, of course, any date or time column. So we need to remove those, right, from the data set. But the other thing to think about is that there are a lot of columns that are correlated with time. An example that we talk a lot about is auto-incrementing IDs. For example, if you have a customer ID that's consistently increasing, right, that feature will be correlated with time and could perfectly predict which rows are from today and yesterday. So we need to exclude those from the model. Chaotic tables, right? Some tables are a lot noisier than others. When I showed you that learn threshold, that's our internal measure of how noisy we've seen the table be over time. We use on publicly available data, for example, Bitcoin transactions are a lot more noisy than, say, the dim customers table of a B2B enterprise. Another issue is clustering across columns. So when you see a data quality issue, it often impacts multiple columns. An example of this is geography, right? You have address, city, state, zip, country. a lot of those would be correlated. We didn't want to give you 10 alerts that are all for the same underlying geographic issue. So we look for those correlated columns, and that's why we were able to show you that the state of New York is correlated with New York City in our example. Performance. This is a big one, right? We wanted this to work across a variety of industries. We have customers who are using this on tables that get billions of rows a day. And the way we handle that is via using sampling in a lot of places in the algorithm so that we can handle these really large and really wide tables. And finally, accuracy. It needs to be sensitive to real changes, but suppress false positives. And so this algorithm will find real unknown unknowns in your data, but it's going to alert less frequently than if you used, say, metric anomalies for everything. So now let's bring it all together. Let's compare how does this AI-driven unsupervised machine learning algorithm compare against validation rules and metric anomalies. And is it easy? It's a lot easier because you just point Anomalo at a table and you get a lot of validation out of the box. Is it interpretable? Because we're using the SHAP values, we can actually explain the anomalies in natural language and not just say like, hey, this looks weird. Is it scalable? Because we're using sampling, we can work on those tables that have millions and billions of rows and dozens to hundreds of columns. Is it sensitive? This is the one drawback of this algorithm. Because we're using sampling, if there are columns that you need to have really prescriptive validations, I always use zip codes as an example, you're still gonna need a validation rule to make every single individual zip code is valid. And then finally, is it comprehensive? I think this is the greatest strength of this algorithm, which is that it works at the table level and it covers all of your columns. I hope all of you found this interesting as a deep dive into our algorithm. We'd love to talk to you more about it at our booth. One of our talented sales engineers can give you a demo so you can see more about it. And I'm gonna turn it back over to Amy to talk about our latest product.
All right, I'm gonna bring us home just a couple more minutes. So thank you, Taly, that was fantastic. As I mentioned, we are just today announcing a new product, right? This is the announcement of Anomalo's unstructured monitoring product. As Taly just showed you, we at Anomalo have been rethinking data quality for quite some time now, right? We've really been raising the bar for what it means to automate data quality at scale within your enterprise. And very, very excited today to tell you that we're doing this again, right? We're raising the bar once again now with our unstructured monitoring product. As you all know and are starting to think about within your enterprise, 90% of enterprise data is unstructured. So though it's fantastic that we can find data quality issues in all of the tabular and structured data via the methods Taly just walked through, now you're gonna be able to bring high quality data to your GenAI models as well, thanks to our unstructured monitoring product. So what is this? What is our product? What do we do? We are now able to take a look at all the text that you're storing within a tool like Databricks and monitor that text for length, duplicates, tone, topics, abusive language, PII, and sentiment, right? Ultimately, what we're helping you do is assign a quality grade to all of that unstructured data. You can see it's kind of hard to see, but you can see the green and the red where we're assigning not only that quality grade, we're also going into the weeds of what these issues are, right? So you can be notified that this information, this document that you have is of a poor grade and has the following data quality issues as a part of it, right? So this is just the beginning. We're super excited. We're pioneering this with a few of our enterprise customers today who are really helping to lead the charge of what it means to bring high quality data not just to analytics and machine learning, but now to generative AI as well. So please get in touch, and you can go here to get in touch and reach out about our private beta for this new product as well. Thank you very much.